until at least one person arrives, I'm gonna stay for 2 more minutes. And if there is no person, I will still start within next 2 minutes. Yeah, let's see whether people are coming. The moment one person arrives, I'm gonna start. One minute. Let's see within these 2 minutes whether people are coming or not. Yeah, nobody's here, but I'm gonna start it anyway. So, good morning, everybody, and it's 10:30, almost 10:30. So, I'm gonna start my day by saying just some random positive sentences to cheer you up and also cheer myself up because I'm always so famous at you know. No, not gonna say it. Like I need to improve myself, so Uh, so I'm gonna tell some random positive things to change myself. So let's start. You're capable of amazing things. You're capable of amazing things. And every day is a fresh start. And today, choose kindness and watch the world bloom. And believe in yourself, and anything is possible. You can do it. Your efforts make a big difference. Even though now you can see it, your efforts make a big difference. And focus on good and good grows. Always try to focus on the good things. The good things will grow eventually. Just believe in yourself. You are stronger than you think. You are very much stronger than you think. Girls and boys, you can do it. Uh, And also, don't forget to celebrate the small victories every single day. It's not the big things. Just if you wake up early today than the yesterday, just celebrate it. Just simple things. If you eat healthy today, just celebrate it. It's just the simple things you need to celebrate. And one thing I want to really mention is the best thing is yet to come. So keep going, even though right now you are still is not in a good place. The best thing is yet to come. So don't worry and be positive and keep going. That's what you need to do. So yeah, start your day by thinking every single positive thing, and you can do it. I mean, just believe in me. You're capable of amazing things. You don't even know. You don't even believe. But there are very much potential inside you that you don't even know. So just try, you are capable of amazing things. Just start right now. Just stop scrolling through the all social medias and try your thing. Try your best. You can do it. Yeah. So that's it for today. These are my 10 positive sentences to cheer yourselves up and also to cheer myself. So I hope you will have a positive day. I hope you stop scrolling through internet and go back to your work and try to make your day as best as possible, because you can do it. Even when just few minutes away from ending the day, you can make that few minutes more positive and more productive. That's what the important thing. Just start right now. If you have something inside you that telling you I should do this, do that, this is the right exact moment to start that. This is the right moment to start doing it. Not tomorrow, not within next month. Just do it right now. You can do it. Yes. Yeah. This is it for today. Bye, guys. Now I'm gonna continue my YouTube live. Yes, of course. Hope life is good and continues to get better every day. Yes. Yeah. So, you guys always try to think positive because things get better. You don't even know when or how, but things get better. Things get better. So, always try to think positive and just accept the reality and just celebrate small things. Life can get better, like unexpected things can happen. Yeah. So I'm gonna end this positive sentences session right now, and I'm gonna start working. You guys can come along with me since I have an exam coming up within 2 weeks. I'm gonna study. That's why I started this live. So you guys can come along with me. I'm just studying here. I will show you my screen. I will show you what I'm studying. Um, yeah, hopefully I will study because yeah, this is the only way I could do it. So let's see how it goes. As I told you, I have an exam, so for that, this is my timetable. It is not visible, it is not clear, but I need to study some of theories. Uh, More especially, I need to study electromagnetism, and I need to study control systems and also visual programming and communication systems and stuff. Yeah, so much more. So today I'm gonna focus on studying electromagnetism. I'm very bad at that. So yeah, let's see how it goes. So first thing I'm gonna do is I'm gonna try to find my past paper. Just give me a few minutes till I find my past paper. Alright guys, always think positive, okay? Like things get better and life is so like unexpected things can happen. Like life is so unpredictable. So how do you know that within few days you're gonna achieve your dream life? Things can be like that. So always try to think positive. Yeah, you can do it. You just don't know it yet, but you can do it. You can do it, girls and boys. Alright, I almost found my past paper. Uh, Yeah, I will study with you. Since I don't even understand theories there, I can study with you guys. I don't want to show. Yeah, this is it. This is the paper. And I don't understand anything, so we're gonna use some AI to get to know what is going on. And maybe you guys also don't know it. Maybe you guys are experts, I don't know. But let's just study with me. So, what question should I choose? The first or the second? Oh, let's choose the first question. Yeah, let's try to get a screenshot and oh, yeah. And then we go to Gemini. Let's start a new chat. You guys can see him the name. It is weird name. So explain the answers just like you explain it to answers just like you explain it to who? It to maybe 12-year-old. My brain is not developed yet, so I guess I'm 12-year-old only. So 12-year-old. Yeah. Alright. Here's a breakdown of these physics problems explained simply with everyday examples. Coulomb's law, the rule of static cling. Imagine you have two magnets. If you bring them close together, they push or pull on each other forcefully. If you move them far apart, you barely feel the force. Coulomb's law is just the science rule for how electric charges, like static electricity, that makes your hair stand up, push or pull each other. The rule is the push or pull between two charges gets stronger if charges are bigger, and it gets weaker very fast as they move far further apart. So, vector form. In physics, a vector just means we are adding an arrow to show which way the push or pull is pointing. So if you write it as a math recipe, it looks like this. I think most of you guys know it. This is very simple, but the problem is the questions are very complex than the equation. So F is equals to 1 over 4 phi epsilon naught q1 q2 over r square. So this is the vector, I guess, r hat. Uh, this this represents the direction. F is equals to 1 over 4 phi epsilon naught q1 q2 over r square r hat. Uh, so this is it. State Coulomb's law in electrostatic and express it in vector form. So I hope that is the answer. Yeah, is that the answer? So let's try to write the answers, because in the exam we have to write the answers. So I'm gonna write them down right here. For the first question, first question, A part A, they are asking state Coulomb's law in electrostatic and express it in a vector form. So think I need to write it as a sentence. Express. I think so. Mm, but let's just write the equation only for now. So the equation is F is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square R hat. So we need to write like this. So F is force. F is force. And I can write it like the push or pull. Like it can be the positive force or a negative force. And also Q1 and Q2 are sizes of two charges. Sizes of two charges, and R is the distance between the two charges. These are obvious things. And then R hat is uh, direction. For now, just let's write it down like this, but I think for the answer script it should be more complex and more professional, but for the understanding I'm just writing this as simple as that. So the second question is, let's try to see what is that. Explain how Coulomb's law can be used to define the concept of the electric field. So, explain how Coulomb's law can be used to define the concept of the Electric field. Mm, electric field. So, uh, they are just simply telling it, but I think answer should be different. So, I'm gonna do is I'm gonna uh, understand using that chat, but write the answers using this chat. Give me answers. Where is the percentage mark? Yeah. So the answers are look. Yeah. This is a statement like Coulomb's law as a statement. This is necessary to get the marks. First, write it as a statement, and then write the equation as in vector form, and then I need to explain what are these things. Right, and then second one is how Coulomb's law can be used to define electric fields. First of all, let's try to understand that. So, what is an electric field? Mm, let's try to understand what is an electric field. Imagine a spider sitting in the middle of its web. Even if you don't touch the spider directly, uh, if you touch the web, you feel it present. An electric field is like an invisible web that every electric charge create around itself. If you put a single charge, let's call the source. out in space. Uh, it alters the space around it by creating this invisible field. If you bring a tiny test charge nearby Coulomb's law says it will feel a force. So we define the electric field E as how much force a single unit of positive charge would feel at that spot. Uh, yeah. So electric field is how much force a single positive charge would feel at that spot. So that is electric field. How much force we a single positive charge will get at that spot. By using Coulomb's law for force, uh, the electric field from a single point charge become is equals to 1 over 4 pi epsilon naught q over r square, because normally F is equals to 1 over 4 pi epsilon naught q1 q2 over r square, but 1 q is becoming 1 because positive single point charge force is we are considering. So E is 1 over 4 pi epsilon naught q over r square r hat. As simple as that. So let's see how should we write it professionally. So the concept of electric field arises naturally by separating the system into source charge that creates alternation in space and a test charge that expires a force due to that alteration. Consider stationary source charge q and small test charge q naught placed at a distance r from it. According to Coulomb's law, the force explained by test charge is q naught. Uh, should I write all this down? The first thing they do is consider the stationary source charge q and small test charge q naught placed at a distance r from it. According to Coulomb's law, the force experienced by test charge is q naught, and then electric field E at the position of the test charge is defined as electrostatic force experienced per unit positive charge taken the limit where the test charge approach 0, so it doesn't disturb the source charge distribution. So when q naught goes to 0, if substituting Coulomb law into definition yields the electric field production by a point charge. I don't understand. Mm, I don't understand, guys. Yeah, if you can understand, please explain me. I'm having very hard time just writing these papers. Yeah, very weird. Show that the electric field distance is it above the midpoint of straight line segment of. Oh, what should I do, guys? These things are very hard. Let's just try this differently. Yeah, let's ask Gemini something like this. Okay. Um. Yeah. Let's start new chat. Yeah. Hey ChatGPT, I want to ask you something. Like, I just already provided you the PDF of the exam, but problem is I don't understand anything. Even when you give answers to it, I don't understand. These things seem super hard, and my tiny brain can't, survive this thing. And um, can you do me a favor? Like, I need to cover this somehow. I need to survive this. I need to pass this exam. So what I'm gonna do right now is I'm going to search every single topic through YouTube. So can you give me exact topics I need to search to cover each and every question? When it comes to topics, there can be several things. As example, if you search electromagnetism, we will get several videos, but you know it may be electromagnetism, but it would never cover the things that I need to cover in the paper. So you need to understand the depth in the paper, and also you need to understand what is exactly in there. So considering all of it, and I need to cover it as fast as possible. So, I have the exam within a few weeks. So, I need to cover this whole thing as fast as possible. So, considering all this, can you give me topics to search on YouTube so that I can cover it? Hi. Okay, I'm gonna put it right here. Okay, let's see how it goes. I need to survive. I need to pass this exam. I don't understand anything. Oh, thank you. Yeah, it is completely normal to feel overwhelmed by physics derivations. You don't have time. Brain electrostatic is notoriously abstract because you are dealing with invisible forces and fields. Breaking these concepts down using visual YouTube animation is best strategy to build your intuition quickly. Uh, yeah. Up. Mm, let's just. Oh, oh, oh. It is not about only just seeing animation and visual things. There can be some several question and answer things, question and answers in YouTube where they discuss things very clearly. So I need to find something like that. And I want you to specify some things so that it will be easy for you. So for our exam, our lecturer told us to refer some resource books. So I don't have time to do it. So can you give me and recommend me some of things to search so that I can get the discussions of the questions inside those resource books in YouTube. Please cover everything, okay? Uh, so the resource books are Elements of Electromagnetism, 6th edition, Oxford Unity, Sad, uh, Sadiku MNO, something like that. I don't understand. And next thing is Purcell EM and Morin DJ, Electricity and Magnetism, 3rd edition, Cambridge University Press. And the next thing is Haidt W and Burke J, something like that. Engineering Electromagnetics, MC Grow Hill. Yeah, these are the resource books that lecturer mentioned, but that lecturer specified one resource book. It is that Griffith DJ 1998 Introduction to Electrodynamics, 3rd edition, Prentice Hall, India, or something like that. So, yeah, hope it is clear to you. So, just give me some Not some, like each and every possible sentence that I can search on YouTube to cover as much as I can in this paper to score above 80% for the exam. Thank you, Kiara. Huh. Yeah, yeah. For the question one, I need to search Coulomb's law in vector form derivation, electric field definition and point charge, and electrodynamic field continuous distribution. Okay, they are not giving me enough search terms, but at least just try to go with the given terms. After searching through all this, I can, you know, go along with the other things. Yeah. 12 equal charges Q are situated at corners of a regular 12-sided polygon. Mm. For instance, one on each numeral of a clock face. What is the net force on a test charge Q at center? What are those? I don't understand. Oh, my brain is so tiny, I guess. Hmm. Let's just, yeah. I'm gonna paste every single question I have. this is the first question. 12 equal charges Q are situated at the corners of a regular 12-sided polygon. 12-sided polygon, okay. For instance, one on each numeral of a clock face. What is the net force on the test charge Q at center? I think this is not a hard question. Yeah. Oh, again another question. Yeah. Second question. Coulomb's law is this: 1045 epsilon naught Q R square. Okay. From this figure, if vectorically added the forces together, we would find F net is equals to 0. This is due to symmetry of the configuration, allowing the forces to cancel. This holds for C as well. Okay. Why they are mentioning it that way? 1, 2, 3, 4, 5, 6, 7, 8. From where I can find this type of polygon? Guys, my first language is not English, so I find it hard sometimes to even understand these type of things. Let's try to tell him to generate a question. I don't know what is going on. This is why I get tired to like even study this type of modules, because it is so get tiring. I just went from studying past paper and then to YouTube, and then again I got tired from the YouTube thing, and then yeah. I couldn't upload the image, so I think Gemini is generating something weird. Yeah, yeah, of course he did. Gemini did something weird, so I need to write this down, I think. Can you generate? Okay. Can you generate a regular 12-sided polygon image? Because I don't know. Alright. I don't know, I still try to find the right method. Even when I'm so behind in this, I'm just trying to find the right method. As I said from the morning, oh right, this is the 12-sided polygon, and as they mentioned in the answer, if I place each and every corner a Q charge, they said that according to the symmetry, the force cancel to each other. So which means finally, as symmetry, we get F net, which means finally force, like a final force or something like that. I don't know. So it is zero. This is due to the symmetry of the configuration, allowing the forces to cancel this whole C as well. Okay, this is very simple. Okay, B. B as a proportion, this would be like adding. Okay, what is the second question? First of all, suppose one of the 12 cues is removed, the one at 6 o'clock. Okay, okay, now I got it. Uh, what is the force cue? Explain your reasoning carefully. Okay, so this is like a clock. Only now I realized it. This is like a clock because we got 12 points. So see, if you may want to mention 6 o'clock, the it will point this thing, which means the q in here will be removed and other thing will be appeared. So according to my knowledge, the thing happen is um, this thing cancel this thing, this thing cancel this cancel this cancel this. Likewise, everything cancel except this. So the force of this charge will stay. This is very simple. I'm not like learning the things that I need to learn yet. These are the very basics. So the way of oh, it is over. See, I'm not learning what I need to learn. I not. I'm not okay. 2.2. Let's see whether I'll get there. And also, there are no explanations, guys. Are there any explanations? Okay, 2.2. 2.2, 2.2, 2.2. Yeah, only this image for a long time. Okay, what's this? So what happens there is, Mickey, we got two charges, Q and minus Q, and we got the angle theta and three different angles, I guess. I think this is R or something. Yeah, as I got to know, this is it. So let's just get a screenshot of it too. Let's just try to get a screenshot of it too. Yes. And then paste it right here. Not here, there. Yeah. I'm gonna paste it right here so that I can get that later. Find the electric field, magnetic direction. As distance is at above the midpoint between equal and opposite charges a distant d apart. Find the electric field, magnitude, and the direction, which means we need to find the value of the electric field and also the direction of it. And the distance is at above. These are very simple things, guys. That's why I get tired because there is no bench between the very simplest thing and the very complex thing. There is no bench. Of course, it starts with very simple thing and then just within few minutes it just go to the very complex that I don't even know what is going on. Yeah, I'm in the very simple stage. Yeah, okay, I need to be patient in here because if I get tired in and skip everything, it will be good. Midsummer night, mid July, you and I forever by crazy days. What was I listening? Oh yeah, this was something that I know. Okay, I should know this. Midsummer night, mid July, you and I forever by crazy days. Summer night, mid July, you and I forever by. Will you still love me when I'm no longer? Will you still love me when I got nothing? Go, aching soul. Will you still love me when I got nothing? Go, my aching soul. Summer night, mid-July, you and I forever by. I hope you have good time listening to my ugly songs. Okay, move on to the solution. So for Q1 is equals to plus Q. The field is okay. As I said, it went straight into the complex. But from the very simplest thing. Yeah, now I don't understand anything. For Q1 is equals to plus Q, the field is R1 is Z square, Z hat. What is going on? I don't understand. What is that? R1 is Z hat, which means Z hat minus D over 2 X hat. What is going on? I don't understand anything. I used to understand everything in the last question. Now I don't understand anything. This is what happened every time I try to study electromagnetism. Yeah, yeah. At least this time, let's just make it a success because every time I just, yeah, this time I can do it. So what can I do? So the question is this. Question is this. This is what the question is. Yeah, this is the question. So they have placed plus q and minus q charges in there, here and there. So the angle is theta. The distances are. So find the electric field, magnitude and direction. I have, yeah. The distance is above the midpoint between equal and opposite charges. A distance is it above the midpoint between equal and, oh right, they have mentioned that the distance is z. Okay, and then what? And then d apart. Okay, I think this from q to minus q they have d distance. Okay, okay. So if I wanna mention the er, which means e electric field, 1 over 4 5 epsilon naught, 1 over 4 5 epsilon naught sigma from 1 I is equals to 1 to n qi over r square I r hat. So what is going on there? So for q1 plus q, the field is r 1 is equals to z hat. The distance is z and the direction is also z hat. R1 is that. Okay. Did anyone understand this? R1 dash is minus x hat. Which means d over 2. Okay. Okay. As simple as that. This is d over 2 x hat. This is z hat. Okay, I got it. Now what we need to do is R1 is z hat minus d minus d over 2 x hat. Why are they saying that? I get very sleepy now. This is what happened all the time when I try to study. Why? This is what happens when I try to study. Why is Is it all the time like this? I don't know. Let's just stop it right here because I am hungry.